Hi, in this video I wanted to talk about some of the basic names that you hear associated with parabolas when you first learn them, and that includes locus and focus and directrix and line of symmetry, all of these things that come up to help us describe parabolas. So let's talk about the focus. Here, for this line, our focus would be right here, and we call it F. And what is that point? Well, in this case, it's 0 and then 1/2. And our directrix, in this case, right, we can also tell exactly where that would be down here at -1/2. And what is the focus in directrix? Well, let me just label this directrix D. Okay, so the focus and directrix, they have a really interesting connection. These two things define the parabola. What is a parabola? Well, a parabola in this case is, right, you can see it right here. It's this curved line, right? But it's really this curved line, or this curve, this parabola, is a collection of points. And the word for a collection of points is the word locus, right? Not a very nice looking word, but it's locus. It means a collection of points. And it can refer to lots of different shapes. Here we're using it to refer to this collection of points. So it's a collection of points. And what a parabola is, right, particularly, is the collection of points that are the same distance from your focus and directrix. And if you find all those points, this is the shape you get, this collection of points. Let me show you what I mean. If we start here with the focus and we draw a line straight down to our directrix, when it crosses the parabola right here at this point, that's exactly halfway between, right, this point, the focus and directrix, because this line is now being cut in half, right? The point here is halfway between. It's the same distance from the focus and directrix. And this idea, this distance idea, holds throughout the entire parabola. So if I was to draw a line from here, the focus, to some random point here, right? And then I draw a line down to the directrix, those two distances are equal because they meet at the parabola, these two purple lines. And this is everywhere along the parabola. These distances here are equal, right? These distances here are equal. And if you keep doing this over and over again, an infinite number of times, what you get is a parabola, that locus of points, that collection of points. So that's the idea behind the focus and directrix. The focus and directrix define, right? They define the parabola because the parabola has to be an equal distance between them. It's all those points that are the same distance from the focus and directrix. In this case, our directrix is just a horizontal line, right? In this case, you would say D equals negative, right, 1/2, because it's all the points along this horizontal line. And in general, there are ways to define this, but the last thing and we'll get to that in our next video, but here, the last thing I think I should point out is, well, two more things, I guess. This line right here, this vertical line, in this case, is our line of symmetry. It's the line that cuts your parabola in half, right? So that in this case, our left side and our right side are mirror images of each other. So that's why this is called line of symmetry, because it cuts your shape into symmetric pieces. So line, oops, I'm still on my line tool there, line of symmetry. Now the line of symmetry will always meet, right, it'll always meet your parabola at the vertex, and that's our last, I think, feature of our parabola. This point right here is your vertex, sometimes called the origin. It's the turning point of the parabola. So sometimes you have parabolas like this, right? And this is the lowest point. So in this case, it would be called a minimum. If you flip, right, this parabola upside down, it would become a maximum. So in here, it's a minimum. Spell it right. Minimum. Yep. Or it could be a maximum. And if you think about the shape of a parabola, just on a basic level, either it's going to look like this, where the vertex is now a maximum. Vertex is a maximum, or it's going to be a minimum, right? If you turn your parabola sideways, you lose, right? The vertex is neither a max or a min. It's just the point, right, where the parabola crosses the line of symmetry. And in that case, there is no maximum or minimum. So there's these three cases to be aware of. If the parabola looks like this, and that's when you have a positive coefficient, right? And you'll get used to that pretty soon. So if it's something like, in this case, this parabola happens to be y equals 1/2 x squared. Well, since the 1/2 here is positive, it's a positive coefficient, you will get a minimum vertex. Here, if the vertex is a maximum, it could have been something like y equals negative 1/2 x squared. And we'll talk later about these sideways parabolas as well, but that's a different case altogether. So we have all these things. Just to review, we have the focus point and the directrix. You can tell where they are because they're always the same distance from any point on the parabola, right? You can pick anything. So if I was to go up here, oops, use my line tool. If I was to go all the way up here, right, I can go down here, and that's the same distance from the directrix to the parabola and the focus. And that's what a parabola is, right? It's that locus of points, that collection of points that are equidistant from the focus and directrix. The line of symmetry always cuts your parabola in half, and the vertex could be a maximum, a minimum, or in this case, when you have a sideways parabola, neither. So those are some basic features. In the next video, we're going to talk about how to kind of use the general form of the focus and directrix to understand the vertex in a nice general algebraic way. All right, thanks.